The test will be about, as I said, 20 questions, roughly 20 questions, if not 25. I have 20, I'm thinking to increase 25. And then the way I'm gonna do it, I'm gonna make it's multiple choice, but the way this works when it comes to grading the test is that show steps next to the solution. Even if you got an answer that's not one of the answer choices, it's fine, you'll get some partial credit. It's a multiple choice, but you still get partial credit for it. So I'm gonna read it either way. And then worst case, you can select any of the answers. So if it's A to D, A, B, C, D, then you got like 25% chance you might get it right. So if you circle the right answer, regardless if you get it right by showing steps or just guessed, you will get the points. But if you circled the wrong answer and then you showed some correct steps, you got partial credit for those steps. Is that okay? Okay, so I made the test the easiest ever. Like, I really mean it. So every time I write a question, I say, okay, how can I make it easier and easier? So I got to the point to get it to be the easiest test. Watch carefully where some questions we write on, if you use a calculator, you would not be able to get an answer. Let's say like I ask you, what's sine 60 degrees? So sine 60 degrees is the square root of 3 over 2. So if you try to put on the calculator is not going to give you square root of 3 over 2. It's going to give you some decimal stuff. Unless if you know how to go backwards, convert the decimal into fraction, and or you might take the answer choices and divide all of them and see which one matches. So if you want to do it in a smart way. Is that okay with you guys? Any questions for me? So I'm gonna start looking at some examples, and while we're going over the examples, it will review some of the concepts for you. Let's start with the vectors. So if I have a vector u with coordinates, or written 5i minus 2j, and vector v with coordinates negative I plus 3j. Okay, so how do you find u minus 2v, for example? We had something similar on the previous test, and some people still get it wrong. U is just 5i minus 2j minus 2 times negative I plus 3j. So that's 5i minus 2j plus 2i minus 6j. And that would give us 7i minus 8j. So that's how this is. What about if you ask to find u dot v? This is called dot product in vectors. And just to recall what u dot v is, u equals, let's say, ai plus bj, and v is ci plus dj. When you do u cross u dot v, it's ac plus bd. You multiply the x plus y. No i's, no j's. So you would always get a number here. It's called scalar. So when I dot it, I multiply the 5 from u and negative 1 from j plus from v, plus negative 2 from u and 3 from v. That's a negative 5 minus 6, which is negative 11. Next, let's talk a little bit about complex numbers and how we apply them. In complex numbers, this is called the standard form. A plus bi is the standard form of a complex number. Is the standard form of a complex number. And what we have here is we learned what we call the trig form, r times cosine theta plus I sine theta. That's called trig form. Or you can write it out as RCIS theta. That's the abbreviation for that. This is trig form. So they can ask you go from standard to trig or vice versa. Also good to recall that the absolute value of z is given by the square root of a squared plus b squared. No I at all, just a squared plus b squared. So write, let's say 8 CIS 5 pi over 6 in standard form as an example. So how do you write this in standard form? Well, again, this means 8 cosine this angle 5 pi over 6 plus I sine 5 pi over 6. What's 5 pi over 6? Is 150 sine 150. What's cosine 150? It's going to be negative square root of 3 over 2 I sine 150 is 1/2. So the table in the back of the book will be the most helpful for you on the test. You know, the table that has the unit circle in it. Now you multiply the 8 and you get negative 4 root 3 plus 4i. So let's call this z. For the same problem, for this answer we just got, we're going to find the absolute value. Of this problem. How do you find the absolute value of this? Well, we gave you the formula earlier. The absolute value was the square root of a squared plus b squared. What's a? Is 4, negative 4 root 3, and b is 4. 16 times 3, right? 48 plus 16. 64. Do you guys see that? So that gives us 8. And in fact, this z will be always the same as r, which was given to us. So on a test, I'm not going to give you the same problem within the same thing and ask you. So it's going to be a separate one probably. Find the absolute value of some other z. Same for z equals negative 2 square root of 3 plus 4i. We're going to find the absolute value of this. So the absolute value of z is going to be the square root of the first one squared plus the second one squared. This is 4 by this 12 plus 16. Square root of 28. And make sure you simplify it. So this won't be one of the answers. You have to multiply it as 4 by 7. The final answer would be 2 square root of 7. Also good to recall, if we are given z1, let's call it r1, cosine theta 1 plus I sine theta 1. z2 is r2 cosine theta 2 plus I sine theta 2. We learned how to multiply them out. z1 times z2, you multiply the r's, r1 times r2, and add the angles. So in multiplication, we add the angles. when we divide z1 divided by z2, we divide the r's and subtract the angles. Also, if z equals r cosine theta in general plus I sine theta, very important to know, if you raise it to the nth power, that's z to r to the n cosine n theta plus I sine n theta. So we raise r to n and multiply the angles by n. Okay, so let's look at an example. We can ask you to find the square root of 2 CIS 30 degrees, all raised to the 10th power. So how does that look like? We can use the formula right above that, which says you raise r, this is r, to that power and multiply the angle by that number, CIS 30 times 10. How do you simplify the first one? You can put it on the calculator if you like, or you can write it as 2 to the 1/2. That's what the square root means. All raised to the 10th power. And this is CIS 300. This gives us by 2 1 by 2 5. 2 to the 5th is 32. We need to find cosine 300 plus I sine 300. This gives us 32 times cosine 300 is what? What's cosine 300? That's in the 4th quadrant. It's going to be positive value, and its cosine is going to be 1/2, but this will be minus I root 3 over 2. Then you distribute the 30 inside. That will give us 16 minus 16 I root 3. So that would be the answer. Recall the polar stuff. Important to know, if you pick a point here, this would be xy, the point xy. We call this theta and r. If you look back in the notes, we proved x is r cosine theta, y is r sine theta. And also x squared plus y squared is r squared by the Pythagorean theorem. So how can a question be asked about this? We can ask you to convert like the one that was in the lecture notes. Let's say r squared equals 9 sine 2 theta So r square, I know it's x squared plus y squared, but what is sine 2 theta? Sine 2 theta is the double angle formula. It has a formula, 2 sine theta cosine theta. But notice, if I want to get this, I'm converting this to rectangular. Rectangular means only x and y. So notice, to get it to rectangular, I just need to get x and y. I need to get rid of r and theta. X and y in the equations, they are attached to r cosine, r sine. So I don't see r's on the left, on the right side. So what I can do here, 9 times 2 is 18. I can multiply by r here next to sine theta and another r next to cosine theta. So that means I multiplied by r squared on both sides. Do you guys see that? So here, this is x squared plus y squared, and the one next to it is x squared plus y squared. So that's a double copy of that. 18. R sine theta is y, and r cosine theta is x. Done. You don't have to simplify further than that. What about if it's r squared is 9 cosine 2 theta? Well, cosine 2 theta, it has a formula. The double angle formula is cosine squared theta minus sine squared theta. Multiply the 9 in to get that. Now this, what do you think we should do now? What do we have to multiply both sides by? We multiply everything by r squared. So r squared here, 9r squared cosine squared theta, 9r squared sine squared theta. Why did I do that? Well, because, let's keep this the same. This you can write it as r cosine theta all square. This you can write it as r sine theta all square. And then this one here is x squared plus y squared and squared, because there are two of them. R cosine is x, so it's x squared. R sine is y, y squared. That's about the polar stuff. So we did vectors, polars, complex numbers. All these are applications to trig. Now we can go back to the original trig that we learned in the earlier chapters. Talk about several things. One, coterminal angles. What are coterminal angles? Coterminal angles are those that they terminate at the same point or at the same angle. So if you draw the unit circle, let's say, and you draw an angle here, let's say it's there, some alpha. Now if you go one full cycle and go back and lands here at the same line, then alpha, and let's call this beta, alpha and beta are called coterminal angles. You can go even the other way around. So if you start somewhere here and then back all the way to the same green line, call this theta and theta as well. So theta, alpha and beta are all coterminal angles. They land at the same point, at the same angle, same terminal side. Next thing, if they give us one of the trig functions, let's say cotan alpha is 3 over 5. And alpha terminates in quadrant 3. Find cosine alpha. So they give you one of the trig functions value and they ask you to find the other one. The easiest way to do this, I personally use a triangle, a right triangle. Label this as alpha. Cotangent is adjacent over the opposite. Adjacent over the opposite. So adjacent is 3, opposite is 5. So that would be, by the Pythagorean theorem, 3 square plus 5 square. 25 plus 9, 34. So I want to find cosine alpha. Cosine alpha is the adjacent over the hypotenuse. But you have to be careful. They said theta terminates in here. In that quadrant, cosine is negative. So be careful not to be tricked if there's a positive and negative. Don't circle the positive ends. Important to know, you already have notes with you, but keep this thing in mind, and its alternative forms, like sine squared is 1 minus cosine square alpha, and cosine square alpha is 1 minus sine square alpha. Keep those in mind, very important. You can use it several times. Another thing good to know, when you are simplifying expressions or proving identities, try to convert everything into sine and cosine. It makes things much easier to work with. So if I ask you to simplify cosine square alpha over 1 plus sine alpha, how would we do something like this? Or something like this. So how do we start with the first one? We can rewrite cosine square as 1 minus sine square. Keep the denominator the same. Now the top one can be factored because that's 1 square. 1 minus sine alpha times 1 plus cosine sine alpha over 1 plus sine alpha. These cancel, so the simplified version would be this, 1 minus sine alpha. So note I use this formula, x squared minus y squared, x minus y times x plus y. This stays the same. Cosine beta, I convert into sine and cosine. That's 1 over sine beta. And this stays the same. Now we distribute this times this and this times this. So sine beta times 1 over sine beta. Sine beta times sine beta square. These cancel out. So you get 1 minus sine squared beta. What's 1 minus sine squared beta is cosine squared beta. So it's important to know that thing that I told you about. Make sure you know the formula for a plus b squared. A squared plus 2ab plus b squared. And a minus b squared. We use them in trig a lot. The other formula is good to know. 1 plus tangent square alpha is secant square alpha. 1 plus cotan square is cosecant square. Good to know that sine square, let's say I want to find 45 degrees. What would that be? This means you find sine 45 and then you square the answer. So that's square root of 2 over 2 from the unit circle square. So that would give us 2 over 4, which simplifies down to 1/2. One question most teachers like to give, let's say they give us secant alpha square root of 3 alpha in quadrant 1, secant beta square root of 7 beta in quadrant 1. They ask us to find cosine alpha minus beta. Okay, so the first step here we always do is we need to write down the formula for this. Keep in mind, this is not cosine alpha minus cosine beta. It's not. So this has a formula, cosine cosine plus sine alpha sine beta. From secant, secant is 1 over cosine. So if secant is square root of 3, then cosine alpha is its reciprocal. Cosine beta is its reciprocal. So cosine alpha is 1 over square root of 3, cosine beta 1 over the square root of 7, plus we can draw a right triangle for each angle. Alpha, beta, cosine adjacent over the hypotenuse. We can do the Pythagorean theorem to apply it here. 3 minus 1, this is the square root of 2. Adjacent over the hypotenuse. 7 minus 1, 6. The good thing that everything is in the first quadrant, so everything should be positive. Sine alpha from the first triangle is the opposite over the hypotenuse. Sine beta from the second triangle, opposite over the hypotenuse. We get 1 over the square root of 21, square root of 12 over square root of 21. That gives us 1 plus 2 square root of 3. Make sure you know the double angle formula. Sine 2 alpha is 2 sine alpha cosine alpha that we used earlier in one of the examples. And cosine 2 alpha, it has 3 formulas. Cosine square alpha minus sine square alpha was used earlier, or 2 cosine square alpha minus 1, or 1 minus 2 sine square alpha. So let's say we have sine alpha 3 over 5, alpha in quadrant 2. Find sine 2 alpha. So again, the formula is 2 sine alpha cosine alpha. From here we can draw a right triangle. I labeled this as an alpha. Sine is the opposite over the hypotenuse. By the Pythagorean theorem, this is 4. 2 times sine alpha is given. Cosine alpha from the triangle is the adjacent over the hypotenuse. And we are in the second quadrant. Cosine is negative. That gives negative 24 over 25. Other good things to review: write an equivalent algebraic expression that involves x only. Say tangent of sine inverse of x. Something like this. So the procedure to solve questions like this, you can always let the stuff inside the parentheses to be any letter you like. Say U. So now all I have to do to finish this, I just find tan of U. What is tangent U? Well, from here, this is equivalent to say sine of U is x. X means x over 1. And why did I write it like this? Because I want to draw a right triangle. U goes here. Sine is the opposite over the hypotenuse. So by the Pythagorean theorem, this is 1 square minus x square. You can try the Pythagorean theorem. Now I want to find tangent u from the triangle. Tangent is the opposite, which is x over adjacent. Everyone okay with this? Recall solving equations, trig equations. If you remember one of them, sine alpha, if sine alpha equals sine beta, the formula to solve this, alpha equals beta plus 2k pi, or alpha is pi minus beta plus 2k pi, k integer. To solve an example on this, let's say solve for sine x minus square root of 3 equals 2 sine x. Make x from 0 to 2 pi. To solve such equation, we can subtract 2 sine x on both sides to bring the sine x to one side and add square root of 3 on both sides. That gives 2 sine x equals square root of 3. So sine x is the square root of 3 over 2. So first, you have to get sine or cosine by itself, as I just did. Next thing is, you ask yourself, what angle is sine square root of 3 over 2? That's pi over 3. 60-degree angles. Now we need to use the formula that I wrote it earlier, that the first one equals the second one plus 2k pi, or the first one is pi minus the second one plus 2k pi. Don't forget k integer. Keep the first one the same. Nothing can be done for the first one. For the second one, if you combine these two, multiply top and bottom by 3, 3 minus 1 is 2 pi over 3 plus 2k pi. Now we can, don't leave it like this, so k is 0, we'll see what it gives us. Pi over 3 is okay, 2 pi over 3, those are okay, they're still within 0 to 2 pi. But if you take 1 or 2 or higher, it's going to be way more, so there's only 2 solutions. Other things to review, in general, if you have a sine bx plus c or a cosine, it works the same way. From these two equations, you need to know the amplitude is absolute value of a, the period is 2 pi over b, assuming it's positive, or you can put an absolute value, and we have the phase shift. Phase shift, how do you find it? always take the quantity inside the parentheses and set it equals 0. Then solve for x. So bx is negative c. X is negative c over b. So negative c over b. That's the phase shift. Find all of the above for y equals negative 6 cosine 3x plus pi over 4 minus 1. Okay, so here the amplitude, the absolute value of negative 6, which is 6, the period 2 pi over 3, phase shift, you set this equal to 0, subtract pi over 4, and then divide by 3, becomes negative pi over 12. When you divide by 3, you multiply the 3 by 4. Next thing to review, make sure you know the law of sines, law of cosines, what they are used for to help in solving triangles. Solving triangles means find missing sides and missing angles. Okay, next let's look at an example. Given triangle ABC with A means angle A is 30 degrees, B is 70 degrees, and small a is 8 cm. Find the length of AC. Of side C. So always draw a diagram, it's easier to see what's going on. C is the side facing angle C. So A is 30 degrees, B 70, and this is 8. Luckily enough, that's not the ambiguous case. So what we need to do here is to find C. Well, we can think about law of sines. So law of sines said sine angle C over C. We use angle A because it's given over A. So let's see what is given. A is 8 sine 30 degrees. And I'm looking for C. To find C, I need angle C. Well, I'm not using B at all here in the equation or the formula, but it has a use. They give me two of them, I can find the third one. C would be 180 minus the sum of the other two angles. 180 minus 100, which is 80. So that goes in there. And now what we can do, cross multiply. C sine 30 degrees equals 8 sine 80 degrees. And then divide 8 sine 80 degrees by sine 30 degrees. Put that in the calculator. Then C is about 16 centimeters. Another thing to review, angle of elevation. So if you have something like this, someone is looking up, this is called, alpha is called angle of elevation. If you're looking down from the top down, this angle is called angle of what? Of depression. Make sure you know these two definitions, what each angle means. Maybe let's try to pick an example about proving tangent alpha minus cotangent alpha equals sine square alpha minus cosine square alpha over sine alpha cosine alpha. So to start with something like this, there's many ways to do this, many ways. If I want to start with this side, let me copy it again. What we can do, we know A minus B over C. It's A over C minus B over C, like that. That's one of the algebraic properties that can be used here. So why am I thinking to split it up? Because if you look on the left-hand side, the left-hand side has something minus something else, right? So splitting it up will give me a difference, as you can see. And after we did the difference, cancel this with this, that gives us sine alpha over cosine alpha. You can cancel one copy from the top with one copy here. Now sine alpha over cosine is tangent alpha. Cotan over sine is cotangent alpha. And that's what we were required to prove.